Okay, in this video, we're going to finish off chapter 4. So this is section 4.6. And let's see, so where's the homework? It might be a little bit easier actually. So the homework problem starts at 3, 5, and 8. Let's see, what's 5? It might be easier to start with a harder problem and then work to an easier problem. Let's start with solving something like this. So this is going to be like number, I guess 10 is good. So we have h of x is equal to 7x over x minus 1 times x plus 5. And then there's a couple of things to solve. It's a bunch of inequalities. We'll do a couple. Oh, this is for, I guess 11 through 15. 11 through 15 uses the same equation. So for example, like with number 12, we want to solve this. H of x is less than or equal to 0. So what we want to solve is 7x over x minus 1, x plus 5. See, everything's written down correctly. Yep, is less than or equal to 0. So in order to do this problem, the first thing we want to do is we can't multiply x minus 1 and x plus 5 to the other side. The reason why we can't do that is because this is an inequality sign. And depending on what x is, this number could be negative. So say if we multiply to the other side, then we would have to switch the sign around if that was a negative number. But it could also be positive. But since x can be basically anything, it's just any number, we don't know if that's this number right here, this x minus 1 or this x plus 5 is going to be positive or negative. So if we multiply it over, we don't know if we need to change this sign or not. So when we're solving these ones, in this particular problem, it's already done for us. Everything needs to be on one side, and then we're just going to have 0 on the other side. So a problem where we don't have things on one side, maybe we'll do this one in a second. Say if we had something like 7x over x is less than or equal to 1 over x. In a problem like this, we can't just multiply x to the other side to cancel it on the right. We would have to subtract 1 over x over. So we have to do something like this. 7 over x minus 1 over x is less than or equal to 0. And then we'd have to get a common denominator on this side. So remember, because we can subtract these things on both sides, that's not going to change the sign. So we could subtract this over to the left and this sign won't change. However, some people would want to do, okay, let's just multiply x on this side, multiply x on this side. It would cancel on that side, and it would cancel on this side. But we can't do that because if we multiply x on both sides, well, maybe we would have to change the sign if x was negative or if x was positive. So we'll do an example like that in a second. So, but for this problem, we already kind of have everything is on one side. We don't have to run into that issue. But anyway, so once your problem kind of looks like this, where you just sort of have one fraction on one side, and then an inequality sign, and then 0 on the other side, that's sort of our goal, which in this problem is already given to us. What we need to do now is, so we look at the fraction on the left-hand side. So there's a top of the fraction and the bottom of the fraction. And we have to figure out what makes the top 0 and what makes the bottom 0. So let's just call those top zeros. We'll do that first. So when we mean top zeros, we just mean when is the top of the fraction? The top of the fraction is 7x. When does this equal 0? And if we solve for x, this one's, just divide the 7 over, we get x is equal to 0. So here's our top 0. Our bottom 0, bottom zeros, just whenever the bottom is equal to 0. So this happens at x equals 1 and x equals minus 5. So we have these 3 zeros. So what we do with these now is we get a number line. Put these onto a number line. So we have minus 5, 0, and then 1. And the only ticks we want to put on the number line are the ticks from the zeros. So we got a 0, x equals 0, x equals 1, and then x equals 5. So those are the only zeros we want to put on the number, or the only numbers we want to put on the number line. And now we have to worry about open circles and closed circles on each of these points. So we already know the bottom of a fraction. This can never be 0. So we got x equals 1 as a 0 and x equals minus 5 as a bottom 0. Both of those are bottom 0. So regardless, we're just going to put open circles on those to get rid of those numbers. And now our top zeros may have closed or open circles, and it depends on the sign. Since our sign is an or equal to, we're allowed to be 0. So anything we get for a top 0 is going to have a closed circle. So this one. If this was just like a strictly inequality sign like that, then we would have an open circle for our top zeros. So basically we can write that off to the side. So top zeros, we have a closed dot. If it's like, this or this, then we have an open dot. If it's going to be this or this. And bottom zeros are always going to be open. Let's not do that, too many dots. Okay, so now what we need to do is, so we're trying to solve this inequality. When is 7x over x minus 1x plus 5 less than 0? So I don't know why it keeps doing this. Anyway, what we need to do now is we need to pick a point here, 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 and here, and we're going to plug it into this equation to see if it's a positive number or a negative number. So we could pick minus 10, minus 3, 1/2, and how about 5? So let's write down, what are we plugging it into? We're plugging this into 7x over x minus 1, x plus 5. So if we plug in minus 10, the top is going to be a negative number because we'd have 7 times minus 10, which is a negative number, divided by minus 10 minus 1, which is a minus, and minus 10 plus 5, which is a minus. So this is going to give us an overall minus sign. If we plug in minus 3, the top's going to be negative. The bottom is going to be, well, a negative there and a positive here. So this is positive. If we plug in, what was the next one? 1/2. The top's going to be positive, and the bottom will be minus and then a plus. So overall minus. And if we plugged in 5, everything's positive. Okay, so now let's see, what's the problem asking for us? It's asking to find this. When is this piece right here less than or equal to 0? Well, less than or equal to 0, that means minus. So we're going to take all of our minus sections. So here's a minus section, and then here's a minus section. And what we just highlighted is going to be our answer. So our answer is going to be minus infinity up to minus 5. And a parenthesis on minus 5 because that open circle. Union, then 0 to 1. Okay, how about let's go back to number 1. So let's say or not number 1, let's do number 2. So number 2 wants us to do x squared plus 2x plus 15, minus 15. Less than 0. So this one's not a fraction. So remember, the first thing to do is just get everything on one side and 0 on the other side. So that's already done for us. And then we wanted to find the top zeros and the bottom zeros. So remember, that was like our first step in this previous problem. We found the zeros on the top, and then we found the zeros on the bottom. It just so happens that this problem down here doesn't have a bottom, but really it kind of does. We can just think of this as just divided by 1. So we still want to do that same step. We want to find our top zeros. Okay, so what makes the top 0? Meaning, what x values give us this? So we need to factor this. This is going to factor into x plus 3, or sorry, x plus 5. X minus 3. So we're going to get x is equal to minus 5. X is equal to 3. So those are our top zeros. And the bottom zeros, well, if you look at the bottom's always equal to 1. So the bottom's never 0. So never 0. So nothing to worry about. for the bottom, because the bottom is always going to be 1, so the 1's never equal to 0. All right, so just like before, we put all of our zeros onto a number line. So all we have are top zeros, so we're going to put on a -5, and we got our 3. And we have to know, is this going to be open circles or closed circles? And since this is a strict sign, there's no or equal to's, like that or equal to part's not there. These are going to be open circles. And so we still got to do that same thing. Pick a point here, pick a point here, pick a point here, and then we'll check those. So 0 in the middle, do 10 over here, and then -11 on this side. All right, so what are we plugging it into? Well, we're plugging it into this, because what we want to solve is this, is x squared plus 2x minus 15 is less than or equal to 0. It's going to be easier to plug it into the factored version. We'll see why in a second. So if we plug in -11, we'll see we're looking at this piece right now. The first term is going to be a minus sign, and the second term is going to be a minus sign. So we're going to get positive. So the reason why we're plugging it into the factored version, we can immediately see that we get positive much quicker. But say if we were going to plug in -11 into this piece right here, we wouldn't be able to tell quickly if it's positive or negative. We would need to use a calculator. But when it's the factored form, we can find quickly whether we plug in a number, it's going to be positive or negative. Because say, just using this example, when we plug in -11, it's easy to see if we plug -11 right here, we get a negative number. And if we plug -11 right here, we get a negative number. So it's just two negative numbers multiplied together, which gives us a positive. We don't see that quickly by just plugging -11 into here. Okay, so -11 is negative, or sorry, positive. Now the middle number was 0. If we plug 0 in, we will get a positive and then a negative, which is negative. Here's positive, here's negative. And if we plug in 10, 2 positives, which is positive. So what we're trying to solve here is, this is a strict sign. We're trying to solve this, less than 0. So less than 0 means, again, we want the negative sections. So you see, we wanted to solve this whole piece less than 0. So less than 0 means negative. So the only negative piece we have up here is this middle part. So our answer for this problem is going to be -5 to +3. Okay, how about okay, let's see. If we do 41. 41 says x to the 3, 3x squared. Let's change this a little bit. So we'll have x plus 3 over here. So what we need to do in this problem is, so like we got to get everything on one side. So let's subtract the x over, subtract the 3 over. So we'll have x to the 3 plus 3x squared minus x minus 3 is bigger than or equal to 0. So now we have everything on one side and 0 on the other side. So we have to find, the top zeros and the bottom zeros. So again, there's really no bottom. We could think of this as the top and this is the bottom. So for our top zeros, let's take the top, set it equal to 0. And to solve this one, we always need a factor to solve for 0. We can factor this one. We can do some group factoring. So from this first term, we could take out an x, these first two, we could take out an x squared, and we're left with an x plus a 3. And from these two, we could take out a minus sign, and we're left with an x plus a 3. And then what you can see next is, well, this has an x plus 3, this has an x plus 3, so let's take that out. And then we're going to be left with x squared minus 1. And then we can continue factoring, so this is x plus 3. And this piece right here is going to turn into x plus 1, x minus 1. All right, so now the zeros we see are going to be x equals -3, x is equal to -1, and x is equal to +1. So, and since there is the bottom's 1, the bottom's never equal to 0. So for our bottom zeros, we have none. So the only, not notes, none. All right, so we go to our number line. -3, -1, 1. Do that same. Oh, so now are these open or closed circles? Well, these are top zeros, so they could be either or, but our sign has that or equal to part. So these are going to be closed circles. Okay, and now what we got to do is pick the points here, 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 and here. So like -10, -2's there, we can do 0 here, and then 3 over here. All right, so what's the problem? We're trying to solve this. We're trying to solve x to the 3 plus 3x squared minus x minus 3 is bigger than or equal to 0. But like we said before, we always want to plug these test points into the factored version. So we just factored this a second ago. This factored to x plus 3, x plus 1, x minus 1. So this is the thing that we're going to plug it into. So if we plug in -10, the first bit, that's going to be a minus sign. This one's also going to be a minus sign. And that one's going to be a minus sign. So that's going to be negative. So minus sign goes there. All right, the next one we plug in is a -2. If we plug a -2 in the first term, we get a positive, then a negative, and then another negative. I don't think that should be the case. Oh, sorry, we're okay. Yeah, this is equal to positive. 2 negatives is a positive, and then positive and positive makes a positive. All right, and the next one was 0. We will have a positive, and a negative, so that gives us a negative. And then the last one, plugging in 3, everything's positive. Okay, so in this problem, it says, look, we want to solve this thing bigger than 0. So bigger than 0, that means positive. So we're going to take all of our positive sections. So this middle piece right here, and this piece off to the right. So the answer for this one will have -3 to -1. Oh, these are with brackets because we have the closed dots. Then from 1 to infinity. And infinity always has the parenthesis. Okay. Let's do -59. So in this problem, we want to solve x plus 1 all over x minus 2 is bigger than or equal to 3. So like we said before, we always want to get 0 on one side and everything on the other side. So the first thing we're going to do is subtract the 3 over. So x plus 1, x minus 2, minus 3, bigger than or equal to 0. Now what we got to do is have to get a common denominator on the left-hand side, which is going to be x minus 2. So we're going to have x plus 1 over x minus 2 minus 3, and then we'll put x minus 2, x minus 2. So there's our common denominator. So what we have is x plus 1 over x minus 2 minus 3 x minus 2 over x minus 2. Then we can combine the fractions. So we have x plus 1 minus 3 x minus 2 x minus 2. And then to simplifying the top, x plus 1 minus 3x plus 6. And see, then we're going to have minus 2x plus 7 over x minus 2 is bigger than or equal to 0. All right, so this is what we are now going to basically like, so once we're at this step, it just basically turns into a problem that we just did Where's it at? Basically this problem. So just now it just took some steps, but we just simplified this into a problem that we've already done. So in order to solve this one that we have in the box, we have to find our top zeros. Because now we have one thing on one side, a fraction on one side, and it is 0 on the other side. That's always the goal. Okay, so our top zeros. Minus 2x plus 7 is equal to 0. So this is subtract the 7, divide by the 2. We'll have x is equal to 7 over 2. Then the bottom zeros. What number is this? Okay, the bottom. Our bottom zeros. Jesus. Okay, so our bottom is just x minus 2. So we have x minus 2 is equal to 0. So then we get x is equal to 2. So here's our two zeros. Put this onto a number line. We have, so 2, 7 over 2. And in this situation, we have the or equal to sign. So our top 0 gets a closed circle. And the bottom 0 always gets an open circle. All right, so now we have to test some points. So here we can plug in 0. So in between 2 and 7 over 2. So 7 over 2 is 3.5. So we can plug in just 3. And then over here, we can plug in 10. And so again, we're plugging that into minus 2x plus 7, x minus 2, bigger than or equal to 0. So if we plug in 0, the top is going to just be 7, so that's positive. And if we plug in 0 on the bottom, we get minus, so this is going to be negative. If we plug in 3, the top will be positive again, and the bottom will be positive, so we get positive. And if we plug in 10, the top is going to be negative, and the bottom is going to be positive, so we get negative. And what we're looking for here is bigger than or equal to 0, so we want our positive sections. So the positive sections are here in the middle. And so our answer is going to be 2 to 7 over 2. Okay, let's do 63. So x plus 6 over x minus 2, bigger than or equal to x minus 8 over x minus 5. All right, so just like before, we got to get everything onto one side, get a common denominator. So let's subtract the x minus 8 over to the left. So we're going to have x plus 6, x minus 2, x minus 8, x minus 5. And now at this part, so the common denominator, we need to get, well, the common denominator is going to be x minus 2, x minus 5. So this one on the left, x plus 6, we need to put an x minus 5 up here, then x minus 2, and we also put an f to put an x minus 5 on the bottom. And on this one, we're going to need to put an x minus 2 on the top. And in addition, the x minus 2 has to go on the bottom. So that's going to be bigger than 0. So now we can combine the fractions. So we're going to have x plus 6, x minus 5, x minus 8, x minus 2, all over x minus 2, x minus 5. So we want to, the bottom's good because now remember we want to find the top zeros and the bottom zeros. So the top zeros, in order to do that, we're going to need to have everything factored. So we need to like distribute everything and then see if we can factor whatever we get. So let's do that first. So the top is going to turn into, we'll have x squared plus x minus 30. That's the first one. And then minus, we'll have x squared minus 10x plus 16 Okay, so then the top is going to become, so we'll have x squared plus x minus 30 minus x squared plus 10x minus 16. All right, so those x squareds cancel, and we have an x and a 10x, so that's 11x, and then a minus 30 and a minus 16, so minus 46, and the bottom is going to be x minus 2, x minus 5. That's bigger than or equal to 0. So now we can find our top zeros easily. So our top zeros, so 11x minus 46. So this is x is going to be equal to 46 over 11. And our bottom zeros, x minus 2, x minus 5 is equal to 0. So here we get x is equal to 2 and x is equal to 5. So we put all these things onto our number line. Let's put this in a box. That's what we want to keep in mind. Okay, so 11 over 40, let's see, we got 2, 11 over 40, or so 46 over 11, and then 5. All right, so again, this, the type of zero. So this is an or equal to sign. So our top zeros are going to get open or closed circles. So the 46 over 11, this gets a closed circle, and our bottom zeros are always getting open circles. Okay, so now we got to plug some numbers in. We can plug in 0. 3 is in here. Oh, what's the number to the right of that? So that's kind of like, we can plug 4.9 in there, and then 10. All right, so we plug in 0. So remember, we're plugging it into this box up here. So if we plug in 0, the top is going to be minus 46, so that's a negative number. If we plug 0 in the bottom, we're going to have 2 negatives. So overall, that's negative. Now, if we plug in 3, the top is still going to be negative. We'd have 33 minus 46, and the bottom is going to be positive and then a negative. So this is a positive number. If we plug in 4.9, so 4.9 times 11, that's more than, so it's going to be positive on the top. And on the bottom, 4.9, so we got positive and negative, so negative. And then if we plug in 10, everything's going to be positive. Okay, and what do we want? So bigger than or equal to 0. So bigger than 0 means our positive sections. So we're going to take this section, and then we're going to take this section. So our answer is going to be 2 with a parenthesis to 46 over 11 with a bracket, and then 5 to infinity. And also, when you're doing your answer, make sure you put these need to be like the zeros. So when doing your work, make sure like these test points, you don't accidentally make the intervals out of those. We have to make the intervals out of these numbers, the numbers that we're putting onto our number line. Okay, so that takes care of that problem. Let's see what else should we do. That actually takes care of all the problems that are on this homework. I guess we can do one more. Let's do 76. So 76, we have 2x over x squared minus 9 plus x over x squared plus x minus 12 is bigger than or equal to 3x x squared plus 7x plus 12. So we got to get everything onto one side first. Let's first make sure we wrote everything down correctly. Okay, let's move this piece over to the left-hand side. So we have 2x and also let's factor all the bottoms. So this is going to factor into x plus 3, x minus 3, then x. This one is going to be x plus 4, x minus 3, then minus 3x, and that bottom factors into x plus 3, x plus 4. And that's going to be bigger than or equal to 0. So our common denominator is going to be x plus 4, x plus 3, x minus 3. So for this first bit, we need to put an x plus 4 on the top and also on the bottom. Okay, this one needs an x plus 3 on the top. And then this one will need an x minus 3 on the top. Okay. So now we have the same denominators. We can combine all the tops together. So we're going to have 2x, x plus 4, plus x, x plus 3, minus 3, x minus 3. Now let's distribute everything on the top. So we'll have from this first bit 2x squared plus 8x plus x squared plus 3x minus 3x minus 9. Okay, so now let's get rid of all those parentheses. So the first bit, we just have 2x squared plus 8x, then plus x squared plus 3x, and then we distribute the minus sign, so minus 3x plus 9. And simplify the top, we'll have a 2x squared. So those 3's go, oh, sorry, 3x squared. We have, so let's see, we got a 2x squared and an x squared, so that gives us a 3x squared. The 3 and the minus 3 cancel, so we just have an 8x. And then the plus 9. Okay, so can we factor the top? Let's see. No, so that's not good. Do we make a mistake? That probably means we made a mistake because I don't see that why they would give us a problem that we couldn't factor the top. Let's go through the work and see if there's a little typo or something somewhere. So let's see, where's the problem? We got 2x over x squared minus 9, x over x squared plus x minus 12, 3x over x squared plus 7x plus 12, okay? So that's x plus 3. So copy the problem down, right? And that's x plus 4x minus 3, and plus 4 plus 3. All right. Then x plus 4 over x plus 4. X plus 3 over x plus 3. All right, so the second line, or, whoops. So that line, this line I believe is okay. All right, what about the next one? We didn't do anything there, so that's okay. 2x squared plus 8x, x squared plus 3x minus 3x plus, oh wait, so minus 3x minus 9, okay, that's good. Plus x squared plus 3x minus 3x plus 9, all right. All right, so we didn't make any mistakes. The book just kind of gave us a problem that was kind of like unnecessarily difficult or just sort of tedious. So we need to find our top zeros and our bottom zeros. So let's do that. So the top zeros, we need to set 3x squared plus 8x plus 9 is equal to 0. But we can't factor that. So we have to use the quadratic formula. So we know that x, so here's our ax squared plus bx plus c. So our a is equal to 3, our b is equal to 8, and our c is equal to 9. Okay, so we have x is equal to negative b plus minus the square root b squared minus 4ac all over 2 times a. So this is going to be equal to negative 8 plus minus the square root of, so b squared, which is 64, minus 4 times a times c. So 3 times 9, which is 27, all over 2 times a, which is 6. But quickly, we're actually going to see, so we'll have minus 8 plus minus, so 64 minus, well, I know it's a negative number, so that means there's not going to be any top zeros. But what is that number? See, so 4 times 27, what could that be? 108. So that's minus 44 on the inside. However, so before when we were doing like I and stuff, we don't do the I for these type of problems. So since we have a negative in here, whenever you're dealing with these inequalities, you don't use an I. For this situation, we have a negative in the square root. So no top zeros. Okay, so we don't have any top zeros for this problem. So let's try to find our bottom zeros now. The bottom, so x plus 3, x minus 3, x plus 4 is equal to 0. So we get x is equal to minus 3, x is equal to positive 3. We don't need to write the positive sign. And x is equal to 4. So let's put all of our zeros onto the number line. In this problem, all we have are bottom zeros, so everything gets open circles. Because bottom zeros always get open circles. And so what is our problem? Our problem was, so we have, oh, okay. So 3x squared plus 8x plus 9 divided by x plus 3, x minus 3, x plus 4. And we want this to be bigger than or equal to 0. So this one's going to be a little annoying to plug in these numbers because we don't have the top being factored. So what would happen if we plugged in minus 3? So is this going to be a positive number or a negative number? I have a feeling that all these are going to be positive, actually. So this is going to be 3 times minus 3 squared plus 8 times minus 3 plus 9. Yeah, so if you've got a calculator, this is going to be, that's a positive number. And then the bottom, we would have, if we plugged in minus 3, we would get, oh, sorry, there's, one second. We didn't, sorry, we made a mistake. We need to pick those points in between the sections. Those are the ones we're plugging in. Remember, we need to pick like something over here. Let's move this down. Sorry about that. So we need to pick a number to the left of minus 3, say like minus 10. Pick a number in between. We can pick 0. Pick a number in here, 3.5. And pick a number over here. We can pick like 7. So if we plug in minus 10, so if you plug minus 10 in so you can get a calculator and check this, but if we plug minus 10 into the top, like if we did 3 times minus 10 squared plus 8 times minus 10 plus 9, this is going to be positive. And on the bottom, we will have, so minus 10 would be negative, negative, and then negative. So the bottom is going to be negative. So overall, this is going to be a minus part. If we plug in 0, the top again is going to be positive. And the bottom, we would have positive, negative, positive. So that's going to be minus as well. And then sorry, let's make sure we're not making it. So that's going to be minus, minus, minus. Okay. And then if we plug in 3.5, let's see, what do we get? Well, top is going to be positive. And then the bottom, we would have positive, 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 which is going to be positive. And if we plug in 7, the top is going to be positive, and then the bottom would also all be positive. So that's going to be positive. So what we were looking for in this problem is we want this thing to be bigger than or equal to 0. So bigger than or equal to 0 means we want the positive sections. Okay, so then what we end up getting is, so from 3 to 4, and then from 4 to infinity. Okay, so that takes care of that problem. So basically, yeah, so all these problems that we've done, this takes care of everything on the homework. Cool, so that's all we really got to do today. So we'll start the reviewing for the test on Monday. So we have on Monday and Tuesday, we'll do review, and then the test is going to be on Wednesday. Okay, cool. So thank you. So I'll see you guys next week.